Now that you understand what a critical value is and how we use it, let's go through that example again, this time for the purpose of understanding what a p-value for an experiment is and how we use that. It's basically the same thing, except this time the focus is on the p and not on the critical value. We have decided in advance that something is only worth paying attention to if it would happen 1 time out of 20, assuming that the null hypothesis was true. So let's go through those 2 experiments again and see what we get. Again, I claim that I have telekinetic powers, and I let you flip a coin to see what happens, and I say I can predict the outcome of the coin, or I can influence the outcome of the coin. Here we go, we get the first one, and I say it's going to be tails, and it's tails. I do it again, and I say it's going to be tails, and again it's tails, and I do it one more time saying it's going to be tails, and it's tails again. What is the p-value of this experiment? In other words, assuming the null hypothesis is in fact true, assuming I have no telekinetic powers, no power, assuming I have no powers, what are the odds of getting this result? Well, we know that. We know that the odds of getting anything in a coin toss is 1 out of 2. And again, 1 out of 2 this time, so if you multiply them, you put them together, that becomes 1 out of 4. And again, this is 1 out of 2, so getting all 3 in a row becomes 1 out of 8. So the p-value for this individual experiment is 1 out of 8. 1 out of 8 is more likely than 1 out of 20. Because 1 out of 8 is more likely than 1 out of 20, this experiment fails. I have failed to do something rare enough to make you think it's worth paying attention to. Let's try it again, this time with the dice. So say someone else says he has telekinetic powers, but this time he's going to use a dice to prove it. And he rolls a 6, or let's say no, he rolls a 1 the first time, and he says he'll roll a 1. And then he rolls another 1, just like he says he will. Now are you convinced that he has telekinetic powers? Well, let's calculate the p of this experiment. The first time to do this, that's 1 out of 6 because there's 6 sides and only 1 face that you want. The second time again, that's 1 out of 6 because there are 2 together. You multiply them and you get 1 out of 36. The p of that, p which is equal to 1 out of 36, is in fact smaller than 1 out of 20. So in this case, he has done something interesting enough to be worth paying attention to. In this case, we reject the null hypothesis, and we, even if we're not convinced that he necessarily has telekinetic powers, we are at least interested enough to think that something is going on. If you understand how we did that and what the reasoning was behind it, you now understand both critical values and p-values.